Hi, this is Dr. Pan recording from Tucson, Arizona. Today we have a question from one of our YouTube subscribers. Let's see how we go about solving this one. To send your own questions, please consider subscribing our channel. Alright, the analysis looks something like this. When we see 2x squared minus y squared where the coefficients are not matched and it's a minus sign here, that gives us pretty good clue it's a hyperbola. If it had been adding over here, we would have an ellipse. So what we need to do then is the complete square, see where the center is shifted to. Now, three things come in mind when it comes to graphing hyperbola, so let's go through them one by one. The first one is that curve always sits on the first term. So if its x term comes first, then it sits on the x curve. Y term comes first, then it sits on the y-axis. Second thing is that center is shifted to x minus cx, y minus cy in the form that minus sign here are very important because it's really from a distance formula. The last one is the slope of the asymptotes. It's really easy in that you just read the size of this box, the asymptote box. The number come from the dimensions, I should say, come from the numbers that under each term. So along y direction, it's ly, and along x direction, it's lx. Once you have the size of this box, the asymptote, the slope, it's pretty easy. It's really just diagonal of this box. So let's use this, apply it to our problem here and see how we go about solving it. Alright, so what I did over here is I gathered the x term here together, I pulled the 2 out, and then I did the same thing for y. Now, be careful with the sign in that I moved the y squared over onto the other side, that becomes minus y squared. Move this one over, it should be plus 6y squared. But because I needed the complete square, I put a bracket back onto this that would change the sign of this. So in essence, I moved this entire chunk, y squared minus 6y, over to the other side of the equal sign. That's another way to think about this one. The two squares that I left over here, the jagged ones, is I need to find a magic number. So those three terms become as a perfect square. And similar for the y term, this, whatever goes in here, would make this three terms become a perfect square. To compensate that equal sign, since I added two things on the left-hand side, I need to take care of on the right-hand side. Let's do that. Alright, so the magic number is you take whatever the coefficient is divided by 2 and square it. That would give you a perfect square of x plus 4 squared. Here's the 2, multiply that. And for this term, I'm going to take coefficients here, minus 6 divided by 2, square that, and the combination of all those three terms becomes y minus 3 squared. The minus sign still copies here, and here's the equal sign. To take care of the equal sign, left side, I took extra 2 times this number here. I duplicate over here, and then on this term, be careful. This one is a positive 9. Since there's a minus sign here, basically I added a minus 9 on the left-hand side. That's what I did on this side. I did the minus 9 on this side as well. Now, clean it up on this on the right hand side, you have minus 32. On this side we have two perfect squares. Normalized one more time, we see that y term becomes the positive, x is negative. So by earlier analysis we know that curve sits on the y-axis, center is at minus 4. Make sure this is the minus 4. So it's minus 4 and 3 for the y coordinates. Length along y direction is square roots of this, which is 4 times square root of 2. And length on x, that's 4. So we have all the info we need. Let's graph it next. The best way I found over the years to graph, once you have all the info you need, is this. You grab the center without giving a reference. Just write it down where center is at, minus 4 and 3. And you're going to go the y unit up, 4 times square root of 2 up, and the 4 units over. Once you have this corner of this box, it's really easy to duplicate the other 3 corners. Now, all 4 corners with the box in place, you connect to the diagonals, that becomes your asymptotes. Since we know the y curve, the curve itself sits along y-axis, so here's the blue one in the curve, that's the function itself. Once you have this all complete, and then we're going to put the reference frame on. Okay, now we'll put the reference point over here so that the center you had earlier is -4 units over and +3 units up. Alright, let's take a look at computer-generated graph for this one. Alright, so here's the computer-generated graph. You can see it's identical to the ones we have. Well, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video. Together we can make math easy again. Have a confident day.